This is a very short video on scopes in the Kotlin Analysis API. And so let's start with a recap once again on how the Kotlin compiler works in different phases. This is a very simple perspective. So the compiler takes in your code and it builds a PSI tree, and each node represents an element in your source. What's missing in this PSI tree is semantic information. That's where analysis comes in. So let's start by looking at an example. Here I have a very simple example of a function that takes in two parameters and I add them in return. It returns an int type. So the semantic model of this is something we looked at before. I have a main method here where I'm calling this method and storing the result in a variable. So what I have here are, in this semantic model, if you look at the overall code in this relationship, what I have here is a global scope. So this add method is defined in a global scope. And what I also have in here is a local scope. Everything inside of this main method, everything inside of the add method is my local scope. So when you take a step back, you see that there are certain symbols that are declared in my global scope. There are certain symbols that are restricted to my local scope. And the compiler has to be able to analyze these different types of scopes. Internally in the compiler, a scope is represented by an interface called a KA scope. So in the Analysis API, what I could do is I could provide it, as we saw before, a KT element, or I could provide it a module that's comprised of different declarations. And I could access information, semantic information, for example, from using these extensions. For example, an extension like an expression type right there. That's what the Analysis API allows me to do. But suppose this expression was defined in different scopes. So the Kotlin compiler has to be able to look at these different scopes. It could be a global scope, a local scope, for example, a function scope, a scope inside of a lambda, and it has to be able to look at all these scopes in order to do this resolution, in order to resolve this, in order for it to ensure that this is some expression type. It has to be able to look at these different scopes. So a scope inside of the compiler is represented using a KA scope, which is an interface, and a scope could be a member scope. It could be a declared member scope or a static scope. So it has to be taken into account all these different scopes, and I have the ability to access information about these scopes with the Analysis API. So what I could do is that if I want to access information about the member scope, I could utilize this extension. Again, the Analysis API, the way it works is by providing you with the information using extensions, and this is an example of it. Underneath the hood, in the Analysis API, when you look at KA session, a session is comprised of providers that give me this information. There are like providers for giving me the member scope information, for example. So this gives me the member scope information. Similarly, there's a way to get information about declared member scope. I could also get information about a static member scope. And there are associated providers in the Kotlin compiler which give me this information. So this is something that's really very important to know. This is one of the ingredients, you could say, in the Analysis API. You have KA types, you have KA scopes, you also have like a way to get diagnostic information that we looked at. You also have KA symbols. So those are really important fundamentals and constructs in the Analysis API. You'll find the same thing if you were looking at the source code for the Kotlin, the Swift export tool. You'll see that there's associated SIR session. So these fundamentals are also used there when you go to extend the Analysis API. So these are all the different scopes that are there. So we looked at in this video series type, scope, resolution, diagnostics.